you're toasted. Git is the industry standard. Most companies, team, and open source projects use Git, so naturally, every job description mentions it. Learning it isn't just a nice to have. It's your get or get out moment. It's a must for any serious developer wanting to land a job. And nonsense Git and GitHub crash course. Unlike a typical Git tutorial, which only scratches the surface and leaves you pushing straight to production like many other interns, we'll go beyond the basics and dive into the real stuff no one really talks about, like how to fix a broken production on a Friday. By the end of this course, you'll not only know how to track code changes and collaborate with your team, but also professionally resolve merge conflicts, fix real-life production issues, write clean commits so your team doesn't have to question your life choices, recover from major and hand it will, you'll know exactly how to fix it and save the day. Use Git through a GUI so you don't have to memorize tons of commands. And even master advanced Git tricks like cherry picking and stashing, because you're here to get good and not just get by. Basically, with this crash course, you'll become your company's go-to Git guy, the person everyone turns to when things go south. And there's a lot we'll cover in this video, and I don't expect you to return to it anytime you need to refer to a command. For that reason, I put together the ultimate Git reference guide, packed with advanced tips and tricks, real-world use cases, and commands to help you level up your Git skills. You can download it for free by clicking the link in the description and use it as a companion to this course and your career. Let's dive right in. So what is Git and why is it so popular? Git is a distributed version control system. Sounds fancy, right? Well, let's break it down. The version control part helps you track and manage code changes over time, while distributed means that every developer's computer has a complete copy of the codebase, including its entire history of changes and information about who changed what and when, allowing you to Git blame someone. Hopefully people won't blame you. But do you really need it? Can you code without using Git? Well, of course you can, but then your workflow would look something like this. You start coding your project in a folder named My Project. And as you make progress, you worry about losing your work. So you create copies, My Project V1, V2, V3, and so on. Then your colleague asks you for the latest version. You zip up My Project V3 and email it over. They made some changes and sent it back as My Project V3 John's changes.zip. Meanwhile, you've continued to work, so now you have My Project V4. You then need to manually compare John's changes with your V4 and create a V5 incorporating everyone's work. And then, a week later, you realize you accidentally removed a crucial feature in V2. You dig through your old folders trying to figure out what changed between versions. Now imagine doing this with 10 developers, each working on different features. It's a recipe for chaos, lost countless hours wasted on a version management system instead of actual coding. Git solves all of these problems and more. It tracks every change automatically, allows multiple people to work on the same project seamlessly, and lets you easily navigate through your project's history. No more final version V2, final, really final zip files. Git does all of this for you, but in a much more powerful and organized way. To get started, you need Git installed. Whether on Windows, Mac, or Linux, it's just 2 clicks away. Google, download Git, and get it for your operating system. Once Git is installed, open up your terminal. Nowadays, I prefer using a terminal built into my IDE. I'm using WebStorm, and honestly, I prefer it over VS Code because everything just works seamlessly. And WebStorm's Git support is extraordinary. You can do so many things you'll learn about in this video. Everything from creating branches, committing, pulling changes, merging, and even resolving conflicts, all without ever leaving the IDE. You can view your Git history, stash changes, and even review pull requests directly inside WebStorm. It makes working with Git smooth and intuitive. After walking you through the essential Git commands in the terminal, I'll show you how you can perform the same tasks more intuitively and efficiently using WebStorm. If you're interested in trying it out, I've included a link in the description where you can download WebStorm for free. Just create an account, click download, and go through the onboarding. Once it's set up, create a new project, and you're ready to start coding with all of these powerful Git features built in. First things first, let's check whether you've installed Git properly. Run git ---- version, and you'll get back the version that is installed on your device. Next, you need to configure Git to work with your name and email. This is just to track who made the changes in the project, so your colleagues know who to blame. Here's the command: git config ---- global user.name, and then in single quotes, put in your name. Once you do that, you can repeat the same command, but this time, instead of changing user.name, we'll change user.email, and here you can enter your email. Press enter, and that's it. You're all set up. Now let's talk about repositories. A repo or a repository is where Git tracks everything in your project. Think of it like a folder that stores all the versions of your code. Simply put, if a folder is being tracked by Git, we call it a repo. Now let's create a new repository. In your terminal, type git init and press enter. As you can see, Git has just initialized a new repository. On top of the success message, we can also see a warning. In previous times, the default name of a branch has been master, but nowadays you'll see main used much more frequently as the name for the primary branch. So let's immediately fix it by configuring the initial branch name. You can copy this command right here, and at the end, you can just say main. Now, considering that we have just changed the initial configuration settings, we have to create a new folder. Create a new one called something like mastering git, open it within your editor, and then rerun git init. As you can see here and here, now we're in the main branch. That means that Git has initialized an empty repository. You won't see any changes yet in your folder, but a hidden .git folder has been created inside your directory. You don't need to touch this folder. Git everything inside, from commit history, branches you'll make, remote repos, and more. Most of the time, Git will already come pre-initialized by the framework or library that you use to set up your project with. That's how integrated Git is into every developer's life. So now that we have this main right here, what does that exactly mean? Well, main is the default branch name of your repo created by Git. Every time you initialize Git, this branch will be automatically created for you. I'll teach you more about Git branches soon, but for now, know that a branch is nothing but a parallel version of your project. Alright, let's add some files and track changes. I'll create a new file called hello.js. And you can see how smart WebStorm is. It automatically asks me whether I want to add it to Git. But for now, I'll cancel that because I want to explain everything manually. Let's make it simply run a console.log that prints hello git. Alongside this file, let's create another new file, and I'll call it readme.md. In here, we can do something similar and say hello git. And now run git status. Git will tell you that you're currently on the main branch, that there are no commits yet, and that there are 2 untracked files, one of which is a markdown document. So to track it, use git add readme.md. After adding a file, we need to commit it. Committing in Git is like taking a snapshot of your project at a certain point. Think of it as creating a whole new copy of your folder and telling Git to remember when you did it, at what time. So, in the future, if anything happens, you'll time travel to this folder with the commit name you specify to Git and see what you had in there. It's essential to commit your changes regularly. Regular commits help you keep your progress and make it easier to revert to previous versions if you break something. You can commit by running git commit -m, which stands for message, and then in single quoted strings, you can add that message. For example, add readme.md file. There we go. Congrats! You just created a checkpoint in your project's history. Now, let's try running git status again to see what it shows. As you can notice, that other file, hello.js, is still there. It's not tracked. We asked Git to track only the README file. To track this file or other files that you may create, we'll have to run a similar command. It'd be too much work to commit each file individually. Thankfully, we have a command that commits all the files we've created or modified that Git is not tracking yet. To see this in action, let's create another file, test.js. And let's add a simple console log that simply console logs a string of test. Now, to track both files and commit them in a single commit action, we can do that by running git add dot. The dot after git add tells Git to add all files created, modified, or deleted to the Git tracking. Next, as usual, we can specify the commit name for this tracked version by using git commit -m add hello and test files. There we go. So now you can see that all of these files are tracked. And since I'm using WebStorm, it also has a hidden .idea folder, so it added it to tracking as well, which I'm okay with. Well done. Now, to see the history of all commits we've created, we can use a new command, git log. And there we have it, our Git history. It contains a commit ID or a hash automatically created by Git, the author we specified when using git config, a timestamp, and the commit message we provided. Great, but how do we switch to an older commit and restore it? Let's say the commit add hello and test files introduces some buggy code, and we want to restore our project to a previous version without these files. Our brain would immediately suggest deleting those files entirely or clearing up their code. And if you do that, you'll most likely break your production because other files depend on those files. So instead of deleting them manually to restore to the first version, where we had only committed the README file, we can use a new command. First, you have to copy the commit hash. It's going to be different from mine, so make sure to copy yours. I'll get this one first that says add readme empty file, and I'll press copy. Then you have to exit this git log by pressing the Q letter on the keyboard. And then you can use a command git checkout, and then you can provide a hash of a specific commit or a branch you want to check out too. Now press enter. Okay, something happened. First of all, our two files are gone. Detached head, experimental changes. What's happening? Well, in Git, there is a concept of a head, which refers to the pointer pointing to the latest commit you've created. When we created our second commit, our head shifted from readme commit to the latest add hello and test files commit. But when we ran git checkout command, we moved the head to the previous older commit. That's why we got this detached head warning. It's a state where the head pointer no longer points to the latest branch commit. And the rest of this message tells you that you can create a new branch off of this commit. But don't worry, your files are still somewhere. When you use a git checkout command, you're simply viewing the repository state as it was at the time of a specific commit. Like right now, we're viewing a snapshot of your codebase at a previous moment in time when we only had a readme.md file. The beauty of this is that all the logs and files, whether created or modified, remain untouched. The git checkout command won't delete any logs or history, so you can safely explore past states without worry. But what if you actually want to discard changes made after that commit? Maybe you want to quickly roll back to a stable state after an issue hits production, tidy up messy commits to look more professional, or undo a bad push you regret making. Perhaps you've been experimenting with a refactor that didn't pan out, or you need to recover from a messy merge conflict. Thankfully, Git provides a few commands that'll help you in these scenarios. And I'll teach you how all of that works very soon. So just keep watching and we'll dive into these more advanced commands that are really going to help you, well, fix a broken production. Now, to go back to our current state, which is called head state, you simply have to run git checkout main. And there we go. Previous head position was at the hash of this checkout, and now you switch the branch to main. You can see the same thing happen right here on the bottom right or the top left, depending where your branching is. And if you made any changes while in the detached head state and you want to discard them, you can do the same thing, git checkout -f, that means force, and then get back to main. In this case, we're good, we're already on main. And that's it. You already know more about Git than most developers do. Of course, we'll dive deeper into advanced use cases and tips and tricks soon, but now let's talk about GitHub and how it differs from Git. Git is used to track changes, whereas GitHub is a cloud platform that allows you to store your Git repositories online and collaborate with others. To push your local project to GitHub, you'll need to link your repository to a remote. But what's a remote? Well, there are two types of repositories. Local repository is a version of a project that exists on your own machine, laptop, or whatever else you use where you do your developer work. When you initialize a repo using git init, you create a local repo in your folder. Changes you make there are private until you push them to a remote repository. So, a remote repo is a version of a project stored on a server like GitHub, GitLab, or Bitbucket. It's used to share code between collaborators and keep projects in sync across different users' computers. When collaborating with a team, you'll have two kinds of repos. Everyone in the team will have a local repository on their machine, and there will also be this one common remote repo from which everyone will sync their local repository versions. Now, head over to github.com and create an account if you don't already have one. Once you're in, press the little plus icon on the top right and select New Repository. Enter a repository name such as mastering Git. Choose whether you want to make it public or private. Leave the Add README file checkbox unticked and click Create Repository. This is a remote repository. Here, you can see your repository's origin. Copy it. When you clone a repository from GitHub, Git automatically names the remote repository as origin by default. It's basically an alias for the remote repository's URL. Now, our goal is to link our local repository to the remote origin. If you haven't yet switched the default master branch name to main, you can do that by running git branch -m main. And this will change the branch name to main, which is a standard practice nowadays. And now we are ready to link our local repo to a remote origin. You have to run a command git remote add origin, and then you have to paste the link to the origin that you just copied, and press enter. And a good thing to know is that you can have multiple remote repositories. You just have to rerun the command and change the origin name to something else. Of course, that's the name of your choice, and then you can also update the new URL. But in most cases, you'll be fine with just one remote repo. Finally, to push your local commits to GitHub, use git push -u origin main. And remember, we used origin here to refer to the remote repository instead of typing the full URL. So press enter, and there we go. This worked. If anything with Git goes wrong, typically it goes wrong at this point, when you're trying to push to a remote repo. So if you don't see what I'm seeing right here, and instead you got some error, typically all of these errors are very easily resolvable. I would just recommend copying the error message, pasting it in Google, and then fixing it right there and then. But in this case, we're good. And now if you go back to your GitHub repository and reload, boom. Your code is now online for the world or your team to see. And okay, you might have already known this. For some of you, that's about as far as you've gone with Git. Create a repo, push your changes, and call it a day. But Git has so much more to offer, especially when you're working within a team. So now, let's take things up a notch and dive into branching and merging. This is where Git truly shines. Branches in Git allow you to create different versions of your project, like making a copy of a project at a specific moment in time. Whatever changes you make in this copied version won't affect the original. The main project or branch stays untouched while you experiment, modify, or add new features in the copied branch. If allowed, you can later merge your changes back into the original project. If not, no worries, the original remains safe and unchanged. When working in a team, using separate branches for different features or bug fixes is essential. It allows you and your team to work independently on different parts of the code without causing conflicts or errors, ensuring everyone can focus on their own tasks. At the start, you'll have one default branch called main. To create a new branch, run git branch and then type a branch name. This will create a new branch. And if you want to switch to this newly created branch, then run git checkout and then enter the branch name you want to check out to. And there we go. Switch to branch name. Now, if you want to go back to main, just run git checkout main. There we go. And here's a little pro tip. There is a shortcut to create a new branch and immediately move to it. To do that, run git checkout with a -b flag and then enter a branch name, such as feature branch. Of course, this branch name and feature branch are just dummy names. Make sure your branch name is short and explains which changes will you be making on that branch. For more tips on how to properly name your branches, you can download the Git reference guide. So let's create and move to this feature branch in one command. There we go. And what I'm about to say next is very important, so keep it in.
All right. Thanks for following to this moment. Please let us know in the comment section where you are watching from. Now, I want to briefly introduce what we just listened to. Um, it's Git and GitHub. We have Git and then GitHub. I'll be dropping um, in the on the comment section so that we can go through it. GitHub. Yes, thank you. This- All right. All right, so let's look at what is Git and GitHub. That is what we just briefly listened to by a coach, and then we want us to look briefly into it. Please, if you are watching, can you tell us where you are watching from in the comment section? Thank you. So, what is Git? Git and GitHub are related but fundamentally different components in modern software development workflow. And then think of a Git as the engine and GitHub as a platform built around that engine. Yes, Git is like a local environment, like a store, and then GitHub is like, so okay, let's say Git is a product, while GitHub is a store where the product is being stored. Yes, and then we look at Git in the core technology as a distributed version control system, that is DVCS. Yes, it tracks changes in files, primarily source code, over time. That is what Git is. It's a version, it tracks changes, and then we see that it's a local environment. Git is a local environment, like for developers, right? People that are into software development that learns coding. Can be a good start if you want to write a program, if you want to develop an app or software, anything. So key capacities of Git, one of it is version tracking, which is every change that is recorded with its metadata. And then we look at branching and merging, offline working, roll back, and then the offline work is full repository exists locally, no internet required. So if you are working with Git, yes, if you are working with Git, one of the things you get to know is that Git use Git works locally. You don't need internet connection. Once you download the app from your on your window environment or your Mac, for those that use any any PC you use, you can get it from your browser. And then once it's been installed, you can now start browsing offline. And then for you to upload what you've done on Git to GitHub, you have to connect it via you have to send it to the what is it called? You have to send it to GitHub through internet. It's just like GitHub is just like your Google Drive. Yes, you know what Google Drive is? Your cloud, and then your, what can we call it again? We can call it OneDrive. for those abi on drive that is on Microsoft Store, and then like that. So core concept of Git, the primary one is repository, project folder tracked by Git, and then we have commits. We have commit, which is snapshot of changes. Once you develop once you write a code and then you code, that is you snapshot, that is the snapshot of the changes you have made, and then the branch and all of that. So I want us to explore this. If you are going into what is it called, yes, if you are going into tech, yes, anything around tech, using exploring the fixture in Git and GitHub, you can, it's going to be a good start for everyone. So let's see the difference between these two words. Let's see the difference between Git and GitHub. So we can see that Git is tool or software, while GitHub is a web platform or service. And then we see that Git has no internet. It does not require you connecting internet before you work on it, but for you to upload what you've done on Git on the cloud, you have to do what? Connect internet. And then we see another function of Git. One of the function is version control. Version control on the Git side, and then on the GitHub we have hosting plus collaboration. Hosting and collaboration in the sense that, let's say you have a group of people, yes, like a team of 10, team of how many, name them, and you want to write a project, you are developing a particular project. All of you can come on the same page. You can be working, let's say all my teammates, you are scattered all over the world. You are in Kenya, you are in USA, and then we want to develop a single app. So we can come together and GitHub and say, okay, this is what I've been able to do so far. I can be able to see your work, you can be able to see mine, like that, like that. Then this is what GitHub does: hosting and then collaboration. You can mingle with people, everybody can bring their own ideas on GitHub. And then we have ownership. We have Git as the owners open source, and then the what is it called? GitHub, right? Is being owned by Microsoft. GitHub is being owned by Microsoft, and then that. So how they work together? Let's see how both Git and GitHub works together. Now, one of it is you can use Git locally to track what changes. Let's say you are coding and then you discover there's a change at the beginning, and then just want to change something. The change you make, you can track it on via using Git, and then you can track it locally without connecting internet. And then we have GitHub remotely. That means when we say remote now, that anybody from anywhere you can work together. Because most people that do remote job, let's say you are working for a company, on that remote job you are doing, you have people you work with, all of you meet. You've never, maybe you guys have never met before, but yet everybody works together as a team. So it stores your whatever you will do, you store it up. You can collaborate with others, you can showcase your project using Git and GitHub. And then why it matters, especially for you, giving your internet in tech, web development, and project building. It's very important. If you are interested in tech related, anything tech related, web development, and building of projects. And then Git controls your system, while GitHub controls your portfolio and collaboration hub. So if you are building something like your marketplace or a media project, you can come to the you can develop your project in Git and GitHub. And then we have minimal learning part, which is practical. You can start with this sequence: install Git, install what Git, and then learn how to make it work. Please, if you are following us, let us know in the comment section. I will be dropping the manual. If you want to go through what we just discussed this evening, I'll be dropping the manual teaching how to install Git, how to use it on that particular page. Let us know in the comment section where you are watching from. And then one of the practical aspects we talk is what install Git available on your system, on your personal computer. If you are using Mac, it's available. Any software you are using, it's available. And then also create after you've installed it, also learn how to use it by using Git, add commits and all of them. There are some keys, basic language we have to learn to get it started.
No battery, please charge.
Okay. Study Git and then learn the basic language model. You have to create a GitHub account. GitHub account, you can't create that one without connecting to the internet. So you have to be connected to the internet and then learn. You have to practice with small projects like a simple empty HTML and then other tools you can place your hand around. Either or you can start with Python. Any of it is available. So after this session, I'll be dropping that in the comment section. So somebody asks, yeah, I see Mama K stores. So you say, what are you doing? La, that is what I just explained. So kindly go through what you have in the comment section. Thank you and have a great evening. It's evening here. Nigeria. I have some of our viewers. I can see one is from Nigeria, right? Yes. Sorry, others from Nigeria, and then the other one from outside Nigeria. It's nice having you around. Thank you.